Today's lesson's on section 9.3, arcs and chords. Let's get started. A chord is a segment with endpoints on a circle. If a chord is not a diameter, then its endpoints divide the circle into a major and a minor arc. Theorem 9.2. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. If arc FG is congruent to arc HJ, if and only if chord FG is congruent to HJ. So in this case, we're looking at here and here, if and only if FG is congruent to HJ. Okay, let's go a little quick on this first theorem today. Example 1A. We have an 82 degrees here. We're looking for this x degrees here. We notice that this chord here is 4 and this chord is 4. Since this is 4 and this is 4, and if this is 82, x degrees is equal to 82. Letter B. We have ourselves this arc here is congruent to this arc here, and we're going to find this x. Okay, so what that basically tells us then is that 2x plus 4 has got to equal 18 because this arc is equal to this arc. Okay, so this chord has got to equal this chord. So 2x plus 4 is equal to 18. And if you subtract 4 from this side and this side, you have yourselves 2x is equal to 14 and x is 7. X is equal to 7. So keep an eye out on these types of questions. Letter C, we have ourselves two chords going across, an SR and an ST. We have 64 degrees here. We have x degrees here. So if we have x degrees here, we know we're going to have an x degrees over here. Okay, so in this case, we got to kind of look at this, what we have here. So we're going to have end up with an x plus an x plus the 64, and that's going to put us all the way around the circle at 360 degrees. 360. Okay, so you might have a question like this that gives you those two chords that are congruent, and then solve for the arcs. Okay, so now we have 2x plus 64 is equal to 360. And if we subtract 64 from both sides, you would have yourself, here let's kind of work through that here. You'd have yourself 296. So your 2x is equal to 296. 96. And by dividing by 2, you have x is 148. So divide by 2 on this side and divide by 2 on this side, and you get x degrees is equal to 148 degrees. Okay, so I'll be on the lookout for that type of questioning coming up. Letter D, circle M is congruent to circle P, and we're going to be asked to find what x is. Okay, so in this case again, so if they're congruent to each other, and we have ourselves this arc here is congruent to this arc, and we're given that this chord is 2x plus 24. And that will tell us then that that 2x plus 24 has got to equal the chord on this circle, which would be 6x. Okay, so your algebra from this point, you're going to subtract 2x on the left and 2x on the right, and you end up with 24 is equal to 4x. And if 24 is equal to 4x, x is equal to 6. X is equal to 6 by dividing by 4 on this side and on this side. And that's letter D. So there you're given that the circles are congruent, and you're given the chords are 6x and 2x plus 4 with the arcs are congruent. So keep a lookout for that type of questioning coming up. Moving on, letter E. We have ourselves circle V is congruent to circle W. We have ourselves 9x minus 8, 78 is this chord, 3x is this chord. We have ourselves 198 on this side. So that's going to tell us a little bit about this other side, okay? So this other side, it would be 360 minus the 198. And so that arc becomes 162. Okay, same as the other one. So, so you want to make sure you realize that because you're given this side of the circle 198, if we subtract from 360, you get 162 on the other arc here. Okay, so now we've got a situation where we have 9x minus 78 is equal to 3x. 9x minus the 78 is equal to 3x. And your algebra here, subtract 9x from this side and subtract it from this side. We'd end up with negative 78 is equal to negative 6x. Okay, by dividing by negative 6 on both sides, you're going to get x is equal to 13. So x is positive 13 for letter E, positive 13. The last one's a quick one, letter F. Letter F here. We've got ourselves a chord here that's congruent to a chord here. We have x degrees of this angle. And if this is 67 degrees, this is also 67 degrees. And that's the first theorem, which goes pretty fast. Okay, the rest of the lesson is a little bit harder. Let's go on to this next theorem. If a line, a segment, or a ray divides an arc into two congruent arcs, then it bisects the arc. Bisects the arc. So if a line, a segment, or a ray divides an arc into two congruent arcs, then it bisects the arc. So you can kind of see a little illustration on circle C here. So we have two theorems here. Keep a lookout for this first one. If a diameter or radius of a circle is perpendicular to a chord, that it bisects the chord and its arc. So the example here is if the diameter AB is perpendicular to chord XY, which is right here, then XZ is congruent to ZY. So then we can conclude that this is congruent to this. And we also can conclude that XB, arc XB, is congruent to BY. Okay, so focus in on the diagram. It may help you with this theorem. Also 9.4, the perpendicular bisector of a chord is a diameter or radius of the circle. So if you have AB is perpendicular bisector of chord XY, then AB is a diameter of circle C. So you've got this chord going across, and if you have a segment AB that is perpendicular to that chord and it bisects that chord, then we can conclude that that is the diameter. So in this case, you have XY is perpendicular to LM. Then you can conclude that LZ is congruent to MZ, and that arc LX is congruent to MX. Okay, so it just kind of reiterates both those theorems up there. Same on this bottom note here, that if we note that this diameter is running through here, we've got a perpendicular, we've got this is equal to this, and we've got this arc is congruent to this arc. Next page. All right, so this is just a page of notes here. We've got ourselves a triangle that's formed. Okay, so you can kind of see back from these figures, what we've got here is a distance, perpendicular distance from the center, okay? Half of the chord, okay, because this side is equal to that, half the chord, and then the radius is right here, okay? So we're going to use the Pythagorean theorem, and we're going to reference a lot of Pythagorean triples. So keep that in mind. Here we go to the next page. Example 2, if circle G, in circle G over here, if the measure of arc DEF is 150, okay, so this whole thing is 150, all right? 150. Now note in the circle, we've got a perpendicular lines here, and we've got our 90-degree angle. So because of that, if we're looking to find DE, because of the previous theorems, we can say that the measure of arc DE is going to be 75. So this is 75 DE, half of the 150. Example 3, circle O has a radius of 13. Radius OB is perpendicular to chord CD, which is 24 inches, which is 24 inches long. Okay, so it says here radius OB is perpendicular. So we're going to just put a few notes in here. This is the radius, which is told us is 13. We're told that that radius OB here is perpendicular to chord CD. So if it's perpendicular, we know that this side is going to equal this side. And if that is, which is 24 inches long, so this is CD, which is 24 inches long. So all the way across is 24. And from our previous theorems, then this would be equal to 12, and this will equal to 12 on this side. So if the measure of CD is 134, so this CD is 134 going across there. Find the measure of CB. Oh, I put 5. If that is 134, find this measure. Well, we know that this is perpendicular here. We know that that's 12 and that's 12. So this little arc here, this measure of CB, is going to be half of this 134, which is 67. 67 degrees. Letter B, find OX. So this, we want to find this little spot here. We're looking for this little x. Okay, and that's a Pythagorean theorem. So if you took your x squared plus 12 squared plus 12 squared is equal to 13 squared. And your x then is x squared, I should say, plus 144 is 169. Subtracting 144 from both sides, you have x squared is equal to 25, and x is 5. You could also use your Pythagorean theorem, triple, which is 5, 12, and 13. Okay, moving on to example 4. If circle A, the diameter is 12, so we know that this diameter is 12. So I'm going to make this right there. Okay, so this is 12. The diameter is 12. So if that's the diameter, this is the radius of 6. Okay, so CD is 8. CD all the way across is 8. So what that's going to tell me then is that this is 4 and that this is 4. Okay, because we were told that CD is 8. And we have ourselves a right angle there. And from our previous theorems, that cuts that into half. So we have 6, we have 4, just from the information that's given us, okay? And then we know that the measure of CD is 90. So CD is 90. So I'm going to put that in there. And we already kind of can conclude then some of these. Let's do, it's going to label that out really well here. So if I know that that is 90, I'm going to say that CE is 45 right away, and ED is 45. All right, let's go ahead. So we're looking for DE. Well, that's 45, just from labeling my little circle there. Okay, half of 90 is 45. Letter B is FD. So we're looking for FD, which is 4. Okay, not too tough. Half of the 8. We were told that CD was 8. Last one is Pythagorean's theorem. So we're going to pull this little triangle here, and we're going to make this triangle out. So what I did is I'm just going to pull this triangle out, go 4, 6, 4, 5, 6. So we're going to end up with a squared plus b squared is c squared. So in this case is x squared. I'll make this x. So x squared plus 4 squared is equal to 6 squared. And if you work this out, you would have 16. And this is 36. Okay. And now we've got x squared plus 16 is 36. And by subtracting 16 from both sides, you'd get 20. And that'd be x squared is equal to 20. All right, so if I'm going to simplify that, I have x is equal to the square root of 20, positive square root of 20. And if I was to simplify that even further, I would have a radical square root of a 4 times a 5. And this is simplifying your radical. So you're going to need to know how to do that when you get off to high school with the algebra 2. 2 square root of 5. 2 square root of 5. If you plug this into a calculator, you would have something like 4.47. Example 5. In circle P, the radius is 13 and RS is 24. Find each measure round to the nearest hundredth. Okay. So if you look at this circle here, we're told that the radius is 13, so you can mark that right away. And I'm just going to make a little line there. That's 13. And we're also told that RS is 24. So if RS is 24, and we have ourselves a 90-degree angle here, this is perpendicular here. So that means if that's 24 going all the way across, this is 12. Okay. And we're looking for, the first one is RT. Okay, so we just found that out to be 12, half of the 24. Letter B, PT. So we're looking for this little guy here. And it's the same as this previous example, and that's 5. That's a Pythagorean triple, if you remember that, or it's the same work as the previous page. Example 5, or example, I don't know if this is labeled 6. Just an extra work here. Okay, so circle Y, okay? So the circle Y, the radius is 34. Okay, so I'm gonna put that in right away. Radius is 34. AB is 60, so you've got yourselves AB is 60. And if this is, okay, this is A, B is 60, which is this arc here. Okay, so this is 30. And this is 30. Okay. So then we're going to look at the measure of AC is 71. Okay, let's start over on this one. I relabeled it. So the radius is 34. Okay, I got that in there. AB is 60. So that would be referencing the chord AB. Okay, so since that this is a 90-degree angle, it's a chord going across there. That segment here, AD is 30, DB is 30. The measure of AC is 71. So AC is 71, so I labeled that in. And I also have BC is 71. Okay, so go ahead. Letter A, the measure of BC. So we're looking for the measurement of BC, which is this 71. Letter B, AD. We're looking for this AD, which is 30. Okay, again, AB is given to us as 60, and this is a radius with a 90-degree angle here, so it's half of that, which is 30. Okay, YD. YD. Okay, so we're going to take 34 and 30. We're looking for this YD here. Okay, and that would be 34 is the Pythagorean theorem again. So yeah, 34, 30, and we're looking for this YD. So I'll call that x squared. So if you use your Pythagorean theorem, you'd have your x squared. Call this x. Okay, and that'd be x squared plus your 30 squared is equal to 34 squared. And if you did that work today, you would end up with x is 16. Next, measure of arc AB would be the 71 plus the 71, which is 142. Segment BD we found to be 30. And segment DC, okay, so we got this little guy here, 30, which is DC. All right, so we found we found this X to be 16, okay? So if our radius is 34, 34 minus 16 is going to be 18. And that would be DC. Okay, let's go to the next theorem. The video is going to be long here, but I do want to finish up so that you don't have two videos. Okay, so it's going to be a little bit longer video, and I'll make sure I understand that for tomorrow's work. This is the last theorem of section 9.3. Got a couple examples to go through. So the note here is, in addition to theorem 9.2, you can use the following theorem to determine whether two chords in a circle are congruent. Move up here. So in the same circle or in congruent circles, two chords are congruent. Two chords are congruent if and only if they are equidistant from the center. Okay, so we have this figure here. Let's focus in on it. So FG is congruent to JH. So FG is congruent to JH if and only if LX is equal to LY. LX here is equal to LY. Okay, so we can use this to solve questions like example 6. In circle P, QR is equal to 7x minus 20. And TS is equal to 3x. Okay, what is x? Okay, within the diagram here, you can see this is 9 and this is 9 here. Okay, so we can use the above theorem to conclude then that 7x minus the 20 is going to equal 3x. 3x. And by subtracting 7x from both sides, you'd have a 7x on this side and a 7x on this side. You would have minus 4x is equal to negative 20. And by dividing by negative 4 on both sides here, you're going to have x is 5. X is 5. So keep a lookout for the use of this theorem. You have to have this 9 and this is 9, and then we conclude that those two chords are equal to each other. Letter B, if circle K, in circle K, JL is congruent to LM. So JL is congruent to LM. And it says here, KN is 3x minus 2. Okay, that's 3x minus 2. And KP is 2x plus 1. 2x plus 1. So these two, KN is 3x minus 2. KP is 2x plus 1. We're also told that these chords are congruent. So we can conclude that these are going to be congruent to each other. So that puts me at 3x minus 2 has to be equal to 2x plus 1. Okay, we're starting out with the chords are congruent, and you've got yourself your perpendicular lines here. So we can conclude that this segment, KN, is congruent to KP. All right, let's do this algebra. So add 2 to both sides, you end up with 3x is equal to 2x plus 3. And subtract 2x from both sides, you would then end up with x is equal to 3 with that algebra. So keep a lookout for that type of questioning as we go forward here. Letter C, algebra. In circle P here, EF, you're told that this chord EF is congruent to GH. Okay, find PQ. So this PQ here. So if we know that we're going to find that PQ, so we got to find out what X is first. And from the above theorem, we can conclude then that 4x minus 3 is equal to 2x plus 3. Okay. And by doing this algebra here, I'll subtract, I'll just do it a little differently. I could add 2x plus 3, add 3 to both sides. I'd have 4x is equal to 2x plus 6. Then I'm going to subtract the 2x. I get 2x is equal to 6, and x is equal to 3. Okay, now if x is equal to 3, we're trying to find PQ. So PQ is 4 times the 3 minus 3. So 12 minus 3 is 9. PQ is 9. 4x minus 3, if x is 3, PQ is 9. All right, 2 more examples will be done for today. Here we go. Chords AC and DF are equidistant from the center. BG and EG are perpendicular to chords AC and FD. If the radius of circle G is 26, find AC and DE. Okay, so if the radius of circle G is 26, so the radius is 26, we then have ourselves, let me see if I can make this a little bit larger here. Oh, wrong way. All right, so maybe we can see a little bit better. Chords AC and DF are equidistant from the center. BG, so let's just take a look at that first statement. AC and DF. Where's AC? Okay. AC and DF are equidistant from the center. So we got those marked as 10. All right, good. So we have ourselves 10 there. And it says BG and EG are perpendicular to chords AG. So we can put those, note that in there. Those are perpendicular. We'll make little corners in there. Okay. So we're told that, and they're equidistant. So we got this 10 and got this 10. So we can kind of conclude that this is going to equal to this. So if the radius of circle G is 26, find AC. Radius is 26. Okay, so this is 26, and this is 26. Okay, so we can find this AB, and this ends up being a Pythagorean triple. Okay, so we have a 10, 26, and this ends up being 24 here. Okay, 24. Okay, and you can do your Pythagorean theorem to find that. 10 squared plus x squared. This is how you'd set that up. 10 squared plus x squared is equal to 26 squared. And that algebra, multiplication algebra calculator work is going to put you at 24. So if that's 24, we know that this is 24. So we are looking for AC. AC is 24. They also want to know what DE is, okay? And DE is, or I should say AC is 48. And DE then is 24. And that is example letter D. Last one today. Let's quickly do this one together. I'm going to back it up. In circle P, okay, CD is 24. Okay, so let's start with that first. In circle P, CD is 24. So this is 24 going across here. And we see that this is a 90-degree angle. So if this is 24, this is CD, that's going to put this at 12 and this at 12. And the measure of CY is 45. Okay, so I'll put that in there too, 45. And if that's 45, we can conclude that this is 45. All right, we also can conclude a couple other things. Same configuration here. We have a 12, we have a 45, we have a 45, and we have 12. Okay, let's start with letter A. Looking for AQ, 12. AQ is 12. Letter B, RC. RC is 12. QB, 12. AB, 24. All right, we've got some arcs to finish up here. The measure of DY, 45. The measure of AB, 90. The measure of arc AX, 45. Letter H, measure of XB, 45. The measure of CD, which is 90. And that's the notes for section 9.3. And keep a lookout for today's work. But that's the full lesson on 9.3, arcs and chords. Get familiar with your theorems. And I'll save these notes and the video, and the assignment will be posted shortly. Thank you very much. Miss you guys all, and hopefully this lesson was beneficial. Talk with you soon.